Welcome to Consider This, the popular podcast series brought to you by the Organization of Legal Professionals. I'm your host, Bridget Novak. This series will focus on the legal industry, current trends, substantive issues, and career perspectives. Each program will run approximately 15 minutes. We hope you stay tuned for this program and join us for others in the future. Today's guest is Herb Roitblatt, co-founder, chief scientist, and chief technology officer of Orcatech. Herb is recognized as the father of concept search and is an expert in search and retrieval technology. He's a co-founder of the Electronic Discovery Institute and a member of OLP's Board of Governors. In today's program, part 2 of our discussion with Herb, we'll be getting into predictive coding and learn about the various methods that fall under that umbrella. Keyword searching isn't the only option out there. There's things like random sampling and clustering and seed sets. Do you want to address some of those and their effectiveness?
Sure. When you do predictive coding, ultimately what you need is a set of example documents. And the example documents have to represent the responsive documents in the case, and then other examples ultimately have to represent the non-responsive documents in the case. Predictive coding is machine learning, meaning that there's a computational process that looks at the examples and based on these examples learns to classify other documents in the same way that the examples were classified. There are three things that you need in order to be able to do effective predictive coding. The first thing you need is your examples have to be valid. That is, they have to actually represent the distinction between responsive and non-responsive documents. If the distinctions are garbage in the examples, the computer can't learn anything from them. The second thing that you need is consistency. That is, the same rules have to apply to all the documents all the time. If a given document is classified one time as being responsive, another time as being non-responsive, then the computer can't learn how to make that distinction. And the third thing that you need is representative. The examples have to actually cover the space of predictive coding. Because if they only cover certain topics and not other topics, if they only cover certain kinds of documents and not other kinds of documents, then you can get good coverage of the kind that they cover, but not good coverage of the other kinds. So all three of those have to be in place for really effective predictive coding. There are lots of ways of making those examples. Some start with clustering, some start with making a seed set, and some start with random sampling. So let's talk about the seed set and the random sampling. In a seed set, somebody goes out and searches for example documents that are examples of the responsive documents. And those examples are then used as the examples of the positive set. They may also search for documents that are examples of the negative set, but different systems require different amounts of negative information. And then the system takes those examples and processes them, extracts the evidence in those examples, and uses that evidence to say, okay, if this document was called responsive, then this document should probably be also called responsive. That's where the prediction comes in. That's where the prediction and predictive coding comes in. The biggest problem with seed sets is that they take a lot of effort to build, and they take and you still have the question about whether they're representative of the whole collection or whether they're only representative of those documents that are easy to find examples. Random sampling, on the other hand, takes a different approach. Random sampling says you may not know how to go about finding responsive documents, but you should be able to recognize them when you see them. It's kind of, I think of it as the Potter-Stewart method of e-discovery, that you don't necessarily have to know how to define pornography, but you do have to be able to recognize it when you see it.
Good one.
So random sampling generates a sample of documents, and some expert, the person whose opinion matters, reads those documents and decides whether each document is responsive or non-responsive. That's how we build the example set using random sampling. After a few of these example sets, the computer starts to predict which documents are responsive and which are not. And the expert, the person guiding the system, can decide whether the computer is right or the computer is wrong. So you also get the advantage then with random sampling that you get feedback on every step as to how well you're doing. And I think that's an important part of the training process. So you know how well you're doing. You don't have to guess and wonder. There are some people who think that, well, I'm an attorney, therefore I ought to be able to find responsive documents, and I'm abrogating my responsibility if I don't go out and seek those documents. I disagree with that. I think that the most important decision that an attorney makes, and the one that requires the attorney's judgment, is whether the document is responsive or not. That it's not how you go about finding them that's important. Rather, it's how you make the judgments that requires the professional judgment of an attorney.
Okay, did you say you wanted to address clustering as well?
Yeah, clustering is not really a predictive coding process. Predictive coding involves machine learning, and it takes example documents, learns from those, and applies the knowledge that it learns from the example documents to identify related documents. Clustering works the other way around. Clustering finds related documents and then asks somebody to judge whether that group of related documents is responsive or not responsive.
Mm-hmm, mm-hmm. So once again, we're talking to Herb Roitblatt, co-founder, chief scientist, and chief technology officer of Orcatech. In addition to which of these methods one might choose to use, Herb, and their various pros and cons, isn't there also the question of the order the things should be done in? I mean, if you're going to use more than one predictive coding method or more than one search and retrieval method, which one you should do first?
Well, in principle, you should use the most accurate one first, the one that, or use the one that gives you the broadest coverage. So if keyword searching is generally thought to be relatively ineffective, what that means is for a given level of effort, keyword searching is relatively ineffective. Not that it can't possibly be made effective by doing enough work. So there are cases that are out there now that are currently under dispute where they did keyword searching first and then use predictive coding after that. Now, if you do the ordinary keyword searching where you get a team of people to sit in a room for a couple of hours and come up with the words that they think are going to be relevant, and you turn that loose as your first pass filter, your end results can't be any more accurate than your first filtering is. If you leave documents behind by your first filtering, then those documents are never going to be part of the quality of the results of predictive coding. On the other hand, if you do your predictive coding first, then if that can be very accurate, I see not just ours but others that are in the 85 to 95% completeness range. It's called recall of the documents that we can identify as responsive. What percentage of those are actually found by the system? And that seems to be pretty high for a lot of the predictive coding systems.
No matter what predictive coding method was used?
I wouldn't go that far.
Okay.
Let's
drill down then.
I would say that with a number of predictive coding systems, the results can be quite good. How good they are is going to depend not just on the technology, but also depends on how people are using it.
Mm-hmm. Was the order of things the basis of the ruling in the Biomet case?
In Biomet, they did what they claimed was a very broad search to begin with. And they didn't claim to have done what they think they did, and what they think they measured was that the original keyword search was very broad because they collected very broadly, they said, and they didn't want to include all the possible broad things they collected in the predictive coding for a number of reasons, including the cost. So instead, they said they searched relatively broadly and then did predictive coding on the results. There, in Clean and in some of the other cases, the judge's decisions are complicated by the fact that the defendants, the people producing the data, had already done a lot of work. So in the clean products case in particular, they had already spent lots and lots of time and lots of money coming up with what they thought was a defensible process to identify responsive documents, and they didn't want to waste that money. And I think that ultimately what the judges there decided, Nolan, and what the judge in the global aerospace case decided is that the people who are producing the documents are in the best place to know what process to use to identify the responsive documents, that they recognize that they have an obligation to produce as complete as they can within the bounds of reasonableness, and it's up to them to choose the method for doing that, and the other side can't compel them to pick a particular method.
Right, and I think that is the bottom line in all these cases, and they go back to Sedona best practices, and the judge is basically telling all sides, cooperate, be transparent, and do the best job you can, be reasonable.
Yes.
Where do you think we are headed in terms of consensus, though, in terms of predictive coding methods? Do you think there's going to be a day anytime soon where 2 or 3 processes rise to the top as the only ones used?
Well, I have an economic interest in saying yes to that, but I think the reality is that we've already got to the point where there's a small number of processes. They all involve machine learning. They all involve being able to process the contents of a document. Where the differences are going to be in the level of effort that's needed. More than the particular technology issues, it's a level of effort. So, for example, if you have to review 35% of your documents in order to do predictive coding, that's a relatively inefficient process. If, on the other hand, you only have to review, say, 2,000 or 3,000 documents to do predictive coding, that's a much more efficient process when you're dealing with 1 million documents. Do you have to review 300,000 or 3,000? That makes a big difference.
And when your time is money.
That's right.
And clients are complaining and seeing.
That's right. So I think that with enough work, that a variety of processes can be effective, and the questions are going to come down to not so much what can I do and what can I not do in order to fulfill my obligations. It's how hard do I want to work when I'm doing it.
The end result will be the same. It just is how long it takes you to get there.
Pretty much. I mean, there are differences. I don't want to say there are no differences among systems, but I think that far overriding the differences among systems are the human factors, things like usability and things like how much effort it takes to accomplish the deals, to accomplish the predictive coding that you're trying to do. The more effort it takes, the less likely you are to get it done well.
Right. Well, predictive coding is a huge topic, but I think you've helped us narrow down some of the key areas of it that we need to focus on, and explained a lot of the concepts and their differences and their similarities. I think they're more similar than most people probably realize.
Yes, they are. There are a few of the technologies that have come to the fore in the last few years. Among these are things like latent semantic analysis and probabilistic latent semantic analysis and Bayesian learning.
Oh my gosh.
And there are
things we're going to have to pay attention to in the future? Oh no.
Well, I'm not sure that you really have to.
Good.
I think that the proof is in the pudding. That is, the systems generally work. The questions are not so much what's the underlying technology behind this from a consumer's point of view, from a lawyer's point of view. It's not so much what is the technology underlying this, because do you really care about the mathematics of the underlying technology? I think the bigger question is how are we going to be able to assess what we're doing? How are we going to be able to measure that we've done a good job here? And I think that's probably the key frontier that we're on right now.
And where do Where do you see that measurability coming from? How can they prove to clients, we use the most effective way, this is what works for us, and we're going to stick with it?
Well, it's in the outcome. So there are studies that are out there that try to compare one system against another system, and they're okay, except what they do is they try to compare the technology absent of the way the technology is used. And you can't really do that. I think that what you need to do is you need to assess each particular case. How well are we doing at predictive coding in this particular case? Because it depends not just on the technology. It depends on the technology and the use of that technology.
Did we find what we were looking for?
Did we find what we were looking for? Have we met our responsibilities? How do we assess that?
All right.
And I think that the measures for doing that are starting to come to the fore. There are the traditional measures that from information retrieval of recall. How complete was our analysis? How complete were we at identifying all the responsive documents? And precision, which is how specific were we at identifying just the responsive documents?
That's all the time we have for this program. It's been great having our guest, Herb Roitblatt, with us today. Herb is co-founder, chief scientist, and chief technology officer of Orcatech. He's recognized as the father of concept search and is an expert in search and retrieval technology. He's also a co-founder of the Electronic Discovery Institute and a member of OLP's Board of Governors. Thanks for joining us today, Herb.
Thank you so much. It's been a pleasure.
I want to thank our audience for tuning in and remind you that we will be producing these programs on a regular basis and that you can listen to this program again and check out future programs in the podcast section of the OLP website. That is theolp.org. Please let us know what topics you'd like us to cover and who you'd like us to interview on future programs. You can email us at info@theolp.org or call us at 760-610-5462. That number again is 760-610-5462. Have a wonderful day, and thank you for listening to Consider This.